Today we are going to learn how to segment object based on your own dataset. So this is an image I've downloaded from Google, and this is the same image after the segmented model that we are going to train. So we will use Decathlon, and this tutorial will help you how to install the Decathlon on Windows and on Ubuntu as well. So first of all, in step number 1, we will discover our dataset, and we will use this website in order to annotate our images. I will also leave the dataset. As you can see, there is a train folder, and those are the images in the train folder. This is a strawberry and a banana. All these images I've downloaded from Google. And basically we are going to annotate those images using this website. Makes sense? So let's start with the annotation process. First of all, we have to upload our train images. So this is our train images. As you can see, we have 12 images. Next, we are going to create our categories. As you can see, we have several categories like apple, strawberry. You can add those categories later. As for now, I'm typing it at the beginning of the process. But if you missed something, you can add it later. So those are our categories. Now we are going to use polygon. It's very important. And now we are adding the dots around each of these strawberry. This is the first one. Now we have to select our category, which is strawberry. Let's draw polygon dots around another strawberry. We don't have to do it for all the strawberry, just several of them. This is the second one. Strawberry. Let's add another one, the third one. Great. Let's move to the next picture. For example, this banana, we are going to draw dots, polygon dots around the first banana. Great. Now important to choose a banana, okay, the category banana. Now let's draw for the second banana. Basically, you have to do it for all your custom images. Don't miss any of those images. This is the second banana. So as you understand, you have to do it for the old images. And then you have to use a Coco and download the JSON file. I've already done it, and I will leave this file, this JSON file, along with the images. As you can see, the test doesn't have those JSON doesn't have this JSON file. We have it for the train and the validation. So now we are ready to start and code some Python code. So first of all, let's load our data and the JSON file, and let's see the annotation along with the images. So but this load process will be based on Decathlon2. So we will load the dataset, we will load the model, and as for now, just watch our images. So let's import the Decathlon2 and the visual, and also the metadata catalog and the dataset catalog. It will help us later to show metadata about the image, for example, the categories. The register Coco is the first function, very important one. In this function, we are matching between the images and the model. It should be register Coco instances. This is the relevant function for segmentation. So let's create an instance of our dataset. We will pass several arguments. The important one is the JSON. And the second important argument is the path for our train images. We also give it a name. We will call it my dataset train. So this registration is for our train images, and we will do the same for the validation images. So let's change some of the arguments, the relevant JSON file and the relevant path for the validation images. You are most welcome to subscribe to my channel. More videos will be published soon. We have to change the direction of the slashes. It's very important. In Windows, it's crucial. Great, let's continue. Now we are going to extract some of the metadata out of this dataset, out of this register Coco instances function. So in order to do that, we will use the function metadata catalog, and we will grab the name that we put in the registration process. For the train, we call it my dataset train. Let's also grab the dictionary. The dictionary contains more information. We will print it and then we will understand more about it. This is part of the Detectron2 model and process. Let's run it. Great, as you can see, a lot of information. Most of the information is the annotation around each of the images and objects inside the images. Let's do the same for the validation. Now let's grab the first image out of the datasets and let's display it. So in order to do that, we have to grab the name and some more information out of the dictionary. So once again, let's print it. As you can see, this is the file name of the first one. We have the height, the width, and all the annotations of the first image. So let's grab it out of the dictionary. Let's get the name, the height, the width, and also the ID of this image. Let's also extract the annotations in order to display it along with the image. We will use the OpenCV function imread in order to load the image from the folder, and this function visualizer will help us to visual our image, and all this -1 process is just converted from BGR to RGB. Let's use the function draw dataset dict of our first image to display our image. Then we are going to grab the image out of this object. Next, we are going to convert it back to BGR to display it using the OpenCV function. And basically what we are going to have is our image along with the annotation. Let's run it. The draw dataset dict draw the dots along with the image. So as you can see, it's a strawberry. These are the dots that I already done, and it was saved in the JSON file. Now let's train the model. The first process, we will run it on Windows. May I remind you that Decathlon on Windows only use the CPU, and on Linux it can run on GPU. It's very important for the training time. As for now, let's run it using Windows. Then I explain later how to do the same with Ubuntu on Linux. Okay, so now we are going to build a model and train it. So we will go to the Detectron website and we will look for the model. This is for object detection and this is for instance segmentation. As you can see, there are several pre-trained models. We will use one of them. Let's use this one, R50FPN model. It's a very good model. I will leave a link directly to this website. You don't have to pre-download the model. The process will download automatically. So as for now, let's put a link for our relevant model. It is Coco instance segmentation / mask RCNN R50FPN. Okay, freex.yaml. Next is the model name. Basically, the model name is the same as the config file. The config file is a file that helps us to load all the weights and all the relevant metadata in order to run the training. Let's create an output here. In this output directory, we will save our trained model. Number of classes is 6. This is our classes, and very important device should be CPU. When we will run it on Ubuntu, we will use CUDA, which indicates our GPU. Now let's define a name. It should be any name you like. Let's call it LP_train. And now we have to put the path for our train images. Don't forget to change the direction of the slashes. I'm using relative path. You can use a full path if you like. Then the path for the JSON file. Let's copy the path for our train JSON file. Great. And don't forget to change the direction of the slashes. Let's do the same for the validation. Let's call it LP_test. The images are on validate folder. And also let's copy the path for the JSON file. All this code will be in my video description, a link for this code so you can download and run it on your local machine. Next is the registration process, very similar when we examine our dataset. So we will use the same function, register Coco instances, and send the same arguments as our previous Python file. Choosing the name, the path for the JSON file, and the path for the images. Let's do the same for the validation data. Great. Let's continue. Now we are going to load our model, and we are going to do it using the getCFG function and the model_zoo object. In order to do that more simple, let's create a function, and we will call this function later. We will call it getTrained_CFG, and we will send all the relevant argument to our custom function. And in this function we are going to do all the process before the train. So we will get our model, get the weights, we will define all the relevant arguments for the model. So we'll do all the preparation for the training. Great, let's start. So let's create an object named CFG, and we'll use the getCFG to get an empty model to our object. Then we will use the merge from file that grab all the information of our relevant and specific config file. Remember, we asked for a specific model when we looked in the website, and then we are going to load our specific weights for this model using the get checkpoint URL, and this will load all the relevant weights of our model. Now let's define the name for our train dataset. Let's do the same for our validation dataset. And next it will be several arguments that impact the speed of the training and how stress we are going to put on our machine. So the first one is the number of workers. I choose the value of 2. You can try a higher value. It really depends of the strength of your local machine. And the next one is number of images per batch. Once again, I use 2, a very low value. You can try a higher value. If you put a higher value, the training will be faster, but the machine will consume more resources. Next is the learning rate. And the next one is how many epochs or how many iterations. I choose 1000. It really depends how many data you have and how long you would like to wait for all the. Okay, there is another value called steps, and you can try playing with this value as well. It will help you to change the learning rate during the training. I leave it as default. I didn't play with this value. The next argument is number of categories. We have 6 categories. We will send this value as an argument for our function. Next is the device. Very important. When you run Windows, it should be CPU, and when you run it on Ubuntu, it should be CUDA. Once again, it's another argument that we are going to send to our function. Output here in this folder, we will store the results of our training. Now let's create a main function. First of all, let's create our output folder. It will be the first process. You can see that I forgot to add import OS. So let's add it. Let's import the OS library, and also let's import Pickle. It will help us to store the results. Now let's run our defined function getTrainCFG and send to this function all the relevant arguments. We will send the path for the config file, the model name, the dataset, this is the validation dataset, and of course before that it's the train dataset. Also the number of classes, the device, and at last the output directory. All the results will be stored on this folder. I use the name is_cfg pickle as for instance segmentation. So the pickle will have all the information, all the train weights of our model. and here is the function in order to dump and store all the process after the training. Everything will be on this folder, on this specific file. Next we have to create an instance for our train object. You can see that I forgot to import the relevant function, so let's add another import. Now we can add it along with this function, default trainer. So this is the process to train our model using the Detectron2. We will send our CFG file, CFG object basically. It's a CFG object with all the arguments, and render.resume or load, we basically start from the beginning, so resume equals false, and then the train function. And basically that's it. We are ready to run our Python program. We have to fix some issues. It should be exist underscore okay. Let's run it. So the train has started. During the training you should follow the total loss. It should be decreasing for every iteration. As you can see now it's 3.153, and now it's 2.949, and now it's 2.592. As you can see, it's print every 20 iterations. So we are not going to wait for the whole process, and we will jump directly to the last phase. Let's wait a few more seconds. As you can see, it took about 4 hours. This is the time for Windows. On Linux it should be faster. It started at 12 and finished at 4, so it's about 4 hours. And those are the categories, our 6 categories of 22 images. And the total loss, you should watch the total loss, it's 0.17, very good value, a very low value from the starting point. Everything is stored here on this folder, my train Detectron2, and this is our final model. It was saved here. So if you would like to run it on an Ubuntu, this is the same Python file. I will leave a link. Here are instructions for creating the relevant environment on Ubuntu. I'm using WSL2. But first of all, you have to create a conda environment, and it's very important to install the PyTorch 1.13. The Decathlon works with this PyTorch version, and then you have to run these several commands. It's all documented, and this is the same Python training command. We have several changes, like it's run on CUDA and not on CPU. You can compare those two Python files. So let's run it on Ubuntu. I've already done all this process, all these instructions. So let's activate our environment on the Ubuntu. As you can see, we are in this folder. This folder is our working folder. You can use your folder as well. Everything will be stored. Our train model will be stored on another folder named Ubuntu in the suffix, and also I changed it to CUDA instead of CPU. And also the pickle is stored in a different location from the Windows location. But basically it's the same code. So let's run it on our Ubuntu environment, just to demonstrate that everything works the same. Start the training, and all the process would be very faster. As you can see, the total loss is decreasing. and decreasing and decreasing. It's a good sign. And basically the process took 40 minutes instead of 4 hours when we run it on a Linux machine. So once again, let's jump to the end. This is the total loss. As you can see, a very good value, a very low value. And now we are ready to test our model. Basically, we have two trained models, one on the Ubuntu, this one, and one on the Windows. This is the Ubuntu. You can see the model, the last file, the biggest one. This is the pickle file. And also we have another folder. Second folder is for the Windows environment. But basically it's the same process. And none of them got a better results, or both have good results. So these are two of our test images, one of strawberry and one is an apple with a banana. So we would like to test if we have two different objects on the same image, if it can detect or segment both objects on the same image. So let's start the testing process. We will import the default prediction function, import OS and pickle for loading the saved model. So this is the path for our CFG file. We can copy it from our previous Python code. This is the pickle. Let's fix it. Great. Let's open the pickle, and now we are going to open it on a read mode, not on write mode, and we will load all the content of this file. Let's copy the output folder that contains the model. This is the one. And the model is stored in our output directory. This is the model underscore final.pth. We saw it earlier. Let's define the threshold of 50%. So if the model predicts higher than 50%, for us it's a good prediction. And if it's a good prediction, it will display it on our image. So we will run our Windows model, so we will choose a device based on CPU. Default predictor is the function that tries to predict our image. So the predictor is basically has all the weights and all the model inside this object. Let's define the names of our 6 classes. We have to keep the same order. Now we have to define the path for our images. Let's create two variables, one for the first image and one for the second image. The first image would be the apple and the banana image. Don't forget to change the slashes. And the second image would be the strawberry image. Okay, the target is to display our first image along with the predictions annotations. So we would like to instance both objects inside the first image, the apple and the banana. So we'll visual our image and grab the annotations out of the predictions. So let's use OpenCV to load our image. Then we are sending this image inside the predictor object, and all the results will be stored in the output variable. Let's run it. Let's wait a few more seconds. As you can see, it's a lot of information. We have the height, the width, and now tensor. As you can see, we have 3 tensors. So those tensors has the dots, and also we have 3 scores, and we have 3 prediction classes 0, 4, and 4. That means that he found 3 predicted classes that are relevant for our categories. So let's grab the information out of this outputs variable. Let's get the predicted classes. As we can see, it had 3 values, 0, 4, and 4. If you watch the classes, 0 means apple and 4 means banana, so it's good direction. Let's say define the flag. If the prediction classes is more than 0, then we will display our image along with the predicted values. Let's start with print once again our predicted values. Next, we would like to print the predicted names instead of numbers. Let's continue code the process of creating our image for display, like converting the channels of the image. Since this function of visual works with the RGB channels, we are converted from BGR to RGB. OpenCV works with BGR and the model works with RGB, so we are changing the channels. And then the draw instant prediction draw the dots over our image. And in order to do that, we will grab the instances out of the outputs variable. And then we are going to convert it back in order to display it using the OpenCV function. So we will use the getImage in order to get back the image from the visual that contains the dots, and we will convert it back to BGR. And then we will show it using the IMShow. Wait for key is waiting for a keystroke. And if there are no predicted classes, we will not display anything. Once again, I forgot to convert it to NumPy, the predicted classes from TensorFlow to NumPy. And also there is a syntax error of the scale, and that's it. Let's run it. Wow, as you can see, we have the apple and the bananas. We have 2 bananas and 1 apple. That's why we had 3 predictions. A very good result. Let's try it on the second image. Let's copy now image path 2 and run it again. So this is a strawberry image. Great, as you can see, there are segmented objects on this image as well. Thank you very much. I hope you enjoyed this video as well. You are most welcome to subscribe. Bye bye.